Hey everyone, and welcome. If you're gearing up for the UPSC exam, you already know that geography is way more than just memorizing maps. It's about understanding the big systems that shape our entire world. And today, we're taking a journey across the globe to really lock in one of the most crucial topics, the major world biomes.
So this quote right here, this is our game plan for today. I want you to picture the Earth not as a random jumble of ecosystems, but as these neat, organized belts that circle the globe, each one defined by its climate. We're going to travel through these belts, starting right at the equator and making our way to the poles.
All right, so here's how we're going to break it down. We'll kick things off in the lush tropical realms, then we'll move through the dry and unique zones. After that, we'll explore the massive grasslands and forests, venture into the cold, frozen frontier, and we'll wrap it all up with a super useful revision snapshot made just for your exam prep.
All right, let's kick off our journey right where the sun hits hardest, the tropics. This is where we find two of the planet's most famous and vibrant biomes, the rainforest and the savanna.
And our first stop is the tropical rainforest. You've probably heard it called the lungs of the world. And for good reason. The sheer amount of oxygen it pumps out is just staggering. This place is an absolute powerhouse of biodiversity.
Okay, so here's the really interesting part. The thing you absolutely need to remember for the exam, it's all about the soil. You'd think with all this heat and rain supporting so much life, the soil would be super rich, right? Wrong. It's actually nutrient poor. The soil, called latisols, gets all its nutrients washed away by the constant heavy rain. So how does anything grow? Well, the secret is an incredibly fast nutrient cycle. Anything that falls to the forest floor decomposes almost instantly, and the plants suck up those nutrients before the rain has a chance to wash them away. And this paradox, this is exactly the kind of thing the UPSC loves to ask about.
Okay, so if we travel just a little bit further from the equator, we hit the tropical grassland, or as you probably know it, the savanna. This is that classic big game country we all know from wildlife documentaries, with those huge sweeping landscapes.
So what makes this savanna? It really all comes down to the climate. You've got a very clear, very distinct wet season, followed by a very clear, very distinct dry season. And that pattern dictates everything. It creates what we call a parkland landscape. Lots of tall grass with these scattered, tough, fire-resistant trees like the baobab. And of course, this environment is perfect for supporting those massive herds of zebras and giraffes and the lions and cheetahs that hunt them.
All right, let's keep moving. As we head further away from the equator, things start to get, well, a lot drier. We're now entering regions that are defined by their lack of water. This is where life has to get really creative, and adaptation becomes the name of the game.
And first up, we've got the hot desert biome. It's no accident that you find these on the western margins of continents. Think the Sahara in Africa or the Thar in India. These places are all about extremes.
Now, before we go any further, you need to know this word. It's super important for this section, xerophytes. It sounds complicated, but it just means plants that have developed some incredible tricks to survive with almost no water.
And boom, here's where that word xerophyte comes to life. With crazy low rainfall and massive temperature swings from day to night, plants need special gear to survive. Think about a cactus, right? It's got those thick, succulent stems to store water, waxy leaves to stop that water from escaping, and super long roots that dig deep to find any drop of moisture. And of course, animals, like the camel, are the undisputed masters of desert survival.
Okay. Get your highlighters ready for this next one, because the Mediterranean biome is a huge favorite with examiners. And that's because its climate is totally unique. It's unlike anything else we've talked about so far. So, what's the secret here? It's all about something called the shifting of pressure belts. This is a huge concept, so listen closely. In the summer, these pressure belts shift north, bringing hot, dry winds from the land. But in the winter, the belts shift south, and now you get wet winds coming in from the ocean. And what's the result? You get hot, dry summers and mild, wet winters. Remember that phrase. It is pure gold for your exam.
So, how do plants deal with those super dry summers? Well, they have this amazing adaptation called sclerophyllous vegetation. In simple terms, it just means they have hard, tough, leathery leaves that are fantastic at preventing water loss during that dry season.
And this slide really brings it all home. That one-of-a-kind climate leads to these special sclerophyllous plants, like cork oak and olive trees. It's also why this region is world famous for growing citrus fruits like oranges and lemons. They love these conditions. And the special soil you find here is called terra rossa.
Okay, Our journey continues. We're moving poleward into the mid-latitudes, and let me tell you, this is the zone of vast grasslands and massive forests.
First up, let's talk about the temperate grasslands, which you might also hear called steppes or prairies. And their nickname, the granaries of the world, pretty much says it all, doesn't it? This biome is incredibly important for feeding the planet.
You find these grasslands deep in the heart of continents, which means they get extreme temperatures. We're talking scorching summers and freezing winters. The landscape is almost totally treeless, just covered in this short, really nutritious grass. That makes it the absolute perfect place for growing wheat on a massive scale, and for huge grazing animals like bison.
All right, pushing even further north now, we hit the taiga, also known as the boreal forest. This is just this enormous belt of coniferous or cone-bearing forest that wraps around the top of the world. And this is a really key point. It's only in the northern hemisphere. Why? Well, there's just not enough land mass down south at these latitudes for it to form.
You can imagine, with those long, brutal winters, the plants here have to be tough. And they are. The conifers have incredible adaptations. Think about it. Needle-like leaves to stop water from escaping, and sloping branches so all that heavy snow just slides right off without breaking them. It's brilliant, really. The animals here are built for the cold, too. Lots of fur-bearing animals like the Siberian tiger and the silver fox, and the soil, called podzels, tends to be quite acidic.
And here we are, the final stop on our journey. We're heading into the frozen frontier, the high Arctic. This is where things get cold, windy, and look almost empty.
Welcome to the tundra biome. And if there's one word you burn into your memory for the tundra, it's this: permafrost. It means there's a layer of soil just under the surface that is permanently frozen all year round. So that permafrost layer is a game changer. It means big trees just can't grow because their roots can't get through the frozen ground. So what you get instead is a treeless landscape of mosses, lichens, and little stunted shrubs. And the animals that live here, reindeer, polar bears, muskox, are true masters of the cold. They often have larger bodies and shorter ears or limbs to hold on to their body heat. Adaptations that scientists actually have names for, like Bergman's and Allen's rules.
Wow, what a trip. We've gone all the way from the equator to the pole. So now, let's do the most important part for your exam prep. We're going to boil all of this down into one powerful revision tool that you can come back to again and again.
Okay, everyone, this is the money slide. Seriously, pause the screen, take a screenshot, write this down, whatever you need to do. This table connects the biome, its specific soil type, and its single most important plant adaptation. Rainforests have leached latisols and use buttress roots. The Mediterranean has terra rosa soil and those waxy sclerophyll leaves. The taiga has acidic podsols and those clever needle leaves. This is pure, high-yield information, perfectly set up for quick revision.
And to wrap it all up, I want to leave you with a question. It's a real civil servant kind of question. As a future administrator, thinking about India's incredibly diverse geography, how does all this global knowledge actually apply here? Which of these biome principles do you think is most critical for making good policy on things like agriculture, water management, or even disaster prevention in our country? It's definitely something to think about. Thanks for joining this explainer.